In this unit number 4, we have seen the syllabus of this unit number 4, central idea of the chapter and the importance of the chapter. Now we'll see this chapter objective and outcomes, and we'll go towards the point number 1. So write down this point, chapter objective and outcomes. In this, write down response to general dynamic loading. Response to general dynamic loading. Response to general dynamic loading using Duhamel's integral. Using Duhamel's integral. Using Duhamel's integral. Full stop. The general dynamic, the general loading will be first objective आहे that general loading will be rectangular or triangular. General loading will be rectangular or triangular. Rectangular loading or triangular loading. Below this, write down second objective to introduce earthquake response spectrum. Earthquake response spectrum. Earthquake response spectrum and tripartite spectrum. TRIPERTITE tripartite spectrum. Third one, to introduce design response spectrum. To introduce design response spectrum. To introduce design response spectrum. And last objective, effect of foundation and structural damping. Effect of foundation and structural damping on its design. बघा या ठिकाणी मी तुम्हाला सांगते ॲज पर द बेस्ड ऑन द चॅप्टर नेम रिस्पॉन्स स्पेक्ट्रम थेअरी. रिस्पॉन्स म्हणजे काय बघायचं आपल्याला. वी हॅव टू सी द रिस्पॉन्स दॅट इज द बिहेवियर ऑफ द स्ट्रक्चर अंडर अ जनरल डायनॅमिक लोडिंग. दॅट इज द फर्स्ट पॉइंट. Second one is the spectra. What is mean by the spectra? Spectra म्हणजे काय? It is one graph which shows an idea about displacement, velocity and acceleration with respect to the time. त्याला आपण काय म्हणणार आहोत? ट्रायपर्टाइट स्पेक्ट्रम. वेगळ्या टाईपचे स्पेक्ट्रम आहेत ते आपण पुढे बघूत. पण तुम्हाला आता कळावं की स्पेक्ट्रम म्हणजे काय? स्पेक्ट्रम इट इज अ वन ग्राफ विच शोज velocity, displacement and acceleration with respect to the time. That is the spectra. And response म्हणजे काय? Behavior of the structure under a dynamic loading. That is nothing but a response of the structure. So based on these two concepts that chapter is based. So there is a most important point. First point is the Duhamel's integral. तर या Duhamel's integral मध्ये आपल्याला काय बघायचं आहे? We'll see first what is the Duhamel's integral, and based on this Duhamel's integral we'll solve some of the small derivations on the first one is the triangular and the rectangular portion. Okay, after under a general dynamic loading, that loading is with respect to the triangular area and the rectangular area, that we'll see here now. So first point is the response to general dynamic loading. What is this? Response to general dynamic loading. Until now, we have studied the response of SDOF system. SDOF is nothing but a single degree of freedom system with harmonic loading. This type of loading is important for better understanding of concept of dynamics. However, real structures are often subjected to loads which are not harmonic. In this section, or in this chapter, we'll study the response of SDOF system to general type of force, and this response can be obtained in terms of integral which can be analytically solved for simple load function and for the general cases. However, it will be necessary to resort to a numerical integration. बघा, म्हणजे ऑलरेडी वी हॅव सीन, आपण काय काय बघितलं, फ्री व्हायब्रेशन वी हॅव सीन, फोर्स्ड व्हायब्रेशन वी हॅव सीन, मीन्स forced vibration means there is some external force, but under this force also we have seen the steady state. Again, second thing, we have seen that transient state. Such a study we have made already, we have seen in the last lecture. But beyond that, there is a some integral portion, the summation of these cross sectional areas, that will become under the integral part. So such a types of the response of the behavior that we'll see here in this chapter with respect to numerical integrations. What is this Duhamel's integral? Now we'll see here. Write down Duhamel's integral. In theory of vibration, in theory of vibrations, Duhamel's integral is a way of calculating the response of linear structures to arbitrary time varying structures with the external excitation, and impulse loading is called a loading which is applied during the short duration of time, and the corresponding impulse of this time of load is defined as product of force into the type of its duration, that is, impulse of force Fi is depicted in figure at time I. During the integral, di is represented by the shaded area is equals to the fi into di. म्हणजे काय म्हणलेलं आहे बघा, that Duhamel's integral is based on the impulse force, that is the based on the impulse force. What is the impulse force? Which is, you can see here, this is a diagram, small diagram. These are the some of the cross sectionals of a Fi, that is the impulse cross sectional. If we take an integration of this, we can calculate if maximum there are the areas, there are the n number of areas, then we will calculate by taking the integral. So they have taken a integral of this Fi. What is this Fi? Fi is nothing but a impulse of the force. You can see here that F is the force, I here is the time t in the x-axis, F is the force in the y direction, Fi is the impulse force. Okay, there are the some of the there are the number of strips are shown on the in the diagram, but based on this diagram, there is a Fi only. We have taken this Fi for one strip, and we'll calculate based on the one strip, that is the Duhamel's integral. Okay, so all of you write down this diagram and the Duhamel's integral. So write down Duhamel's integral. Duhamel's integral in theory of vibration. In theory of vibration. In theory of vibration. In theory of vibration, Duhamel's integral, Duhamel's integral in the theory of vibration, Duhamel's integral is a way of, is a way of, is a way of is a way of calculating, is a way of calculating, is a way of calculating the response of the response of linear system, the response of linear system and structures to arbitrary time, structures to arbitrary time, varying, varying external excitation, external excitation on impulse loading, on impulse loading is a load, impulse loading is a load which is applied, which is applied during, during, during a short duration of time, during a short duration of time, during a short duration of time. The corresponding impulse, the corresponding impulse of this type of load, of this type of load is defined as, is defined as the product of force and the type of its duration, and type of its duration. For example, the impulse for the impulse force, the impulse force and the type of its duration. Oh, sorry, impulse force Fi, the impulse force Fi, which is shown in figure, the force Fi, which is shown in figure at time, at time t, during the integral, during the integral, di is represented during integral, di is represented by the shaded area, represented by the shaded area, and and is equal to Fi into di, Fi into di, Fi into di. So all of you draw this diagram. All of you draw this diagram fast. Okay. This impulse, you can write here what is meant by this impulse. Impulse is equal to f of I into di that we have seen. Now this impulse acting on a body of mass m produces a change in velocity which can be determined from Newton's law of motion. आपला फॉर्म्युला काय बेसिक फॉर्म्युला व्हॉट इज द बेसिक फॉर्म्युला न्यूटन्स लॉ एफ इक्वल टू एम ए so you can see here this is a f into I, that is with respect to the impulse I, and mass into acceleration, that m is same here, acceleration, which acceleration if we take the derivative dv by dt, that is mass into acceleration will get directly. Okay, so based on this fi is equal to mass into dv by dt, that is the f is equal to ma, which is based on the Newton's law of motion. This impulse acting on a body of mass m produces a change in velocity which can be determined from Newton's law of motion, namely mass f is equal to mass into acceleration. Okay, so based on this I have written here f of I, that is the f, that is the force, that is the impulse force, is equal to m into a, where m is the mass into a is the acceleration, that is acceleration is nothing but a dv by dt, so it is nothing but a acceleration is dv by dt. So based on this f of I is equal to dv by m into dv by dt. Rearranging the terms on the both the sides, dv is equal to f of I into di, that is the dt divided by m, that rearranging the terms, where f of I into d tau is the impulse force into time, that is the impulse, and dv is the incremental velocity, dv is the incremental velocity. The incremental velocity may be considered as initial velocity of mass time t. So we know that undamped free vibration system, the solution, what is our undamped free vibration system? So based on this, we'll calculate the response. Okay, it's already we know, already we have solved the test, some of that derivation for the undamped free vibration system. So from that we'll get an x of t is equal to x naught cos omega n t plus x dot naught divided by omega n into sine of omega n t. So considering the initial velocity, f e naught is equal to f in f tau into f tau into d tau divided by m.